So we're just taking a few minutes here to go over your warm-up. So quadrant 1, everything there is positive. We would say all things are positive. In quadrant 2, just to focus your attention on what's positive there, do you see how sine is positive? That's the only thing that's positive, but keep in mind the reciprocal trig function would also be positive. So in this case, sine is our positive function. I'm going to underline that S there. In quadrant 3, notice that tangent is positive.
Okay.
And, just a little side note there, cotangent would also be positive. So tangent's positive in quadrant 3. And then lastly, in quadrant 4, we see that cosine is positive. And, just to go along with that, not only is cosine positive, but then secant would also be positive. So the idea is when you look at this chart, we're going to kind of memorize it, but I'm going to give you a little mnemonic device to help you out. And do you see how I underline the A, S, T, C? Maybe you've heard the phrase, all students take classes, or all students take chemistry, or my name's Stephanie, I'll say all Stephanies take your chocolate, any of that. ASTC is a little mnemonic device known in trigonometry that helps students remember which trig functions are positive in which quadrant. So if you just remember which ones were positive, all the other ones are negative. So again, in quadrant 1, everything is positive. In quadrant 2, just your sine and then cosecant are positive. In quadrant 3, tangent is the only positive one, so is cotangent. And then lastly, in quadrant 4, cosine and then secant are positive in quadrant 4. So all students take classes. We were trying to come up with other things that students take, like all students take chemistry, or all students take contemporary history, or choir, creative writing, thinking of all the C classes we have here at the high school. I'm starting to run out of them. Anyway, all students take classes is usually the most common. All students take calculus. I have heard that one. Yes, as a math teacher, why did I not say that one? All students take calculus. Yeah, that's great. Eventually, Getting there. All good things in time. Okay, questions about your warm-up? Okay, remember the goal for today, though. You're going to be able to, when given a trig function value, so if I give you a trig function value, you're going to be able to sleuth out what x, y, and r are. Sounds so weird when I say it that way. What x, y, and r are, and then find all 6 trig function values from that. So some detective work is needed to be successful with today's lesson. All right, let's do this. So here in key point 1, I'm just identifying some important information about the quadrants. Just to review, if we're chilling in quadrant 1, in degree measure, you're looking at angles between 0 and 90 degrees. If we're doing this business in radians, you're looking at values from 0 to pi over 2. So in this case, remember that your x values are positive. Another way of saying positive in math class is greater than 0. Your y values are also greater than 0. So x is positive and y is positive. In quadrant 2, those angles are between 90 and 180. If we're dealing with radian measure, that's going to be between pi over 2 and pi. In quadrant 2, x values have to be negative, so those are less than 0. But your y values, you still go up to plot those. Those are bigger than 0. In quadrant 3, Those angles go from 180 to 270. In radian measure, that would go from pi to 3 pi over 2. And everything's negative in quadrant 3, as far as x and y are concerned. So x and y are both negative. In other words, they're less than 0. And then lastly, in quadrant 4, you're looking at angles from 270 to 360 to finish out that full rotation. So we're going from 3 pi over 2 to 2 pi. So this is where x is bigger than 0 and y is less than 0. It's awesome. Awesome job, awesome job. So our first problem of the day, in example 1 here, it says, given that we know that the tangent of theta is negative 5/4 and that cosine is positive, we're asked to find sine and secant. Okay, the first thing we need to figure out, in every problem we do today, the first thing I'm going to try to sleuth out is what x, y, and r are. I need that information. To do that, I first look to the given. And the given information in today's lesson comes at us as a trig function. So I'm highlighting the given information in this case. They're telling me out of the gate here that tangent of my angle is negative 5/4. Now remember that tangent is defined as y over x. Remember that? So basically, right out of the gate, they're giving me information, always actually, about 2 of the 3 letters. So they're always telling you 2 of the 3 letters. It's just almost like a secret code that they're giving you.
Oh, negative 5.
Well, we got to be careful though, Isabel. You're actually right. But why did you make the 5 negative? Because couldn't the 4 be also negative?
Oh, so x is negative 4 and...
So whenever you're given a negative, the job is to figure out where the negative goes. So does it go to the top or does it go to the bottom?
You can't go to both, can it?
No, because that would be a positive quotient. Yeah, you can't put it on both because then we would have a positive value. So you got to look at the other clues that they gave you in the problem. Remember, they told you something about cosine. In other words, they're giving you something about x. Cosine values are x values, right?
Yeah. So...
A couple people know. Go ahead, Scarlett.
Since the 4 is for cosine and cosine is greater than 0, the negative sign has to go with the 5.
Yeah, good.
Yes, Scarlett.
So since they're giving us this information about x up here, they're telling us cosine is 0 or bigger than 0, so x has to be bigger than 0. That means the 4 has to be positive. So the 5 is negative. Annabelle, your intuition was correct.
Oh, yay.
Yeah, on this one. You just gotta watch. So that is the hardest part. You're gonna be fine with getting the numbers in this, no problem. It's gonna be the plus or minuses that throw you a little bit. So in this case, I now know y is negative 5 and x is 4. Does anybody remember how we find r? Pythagorean theorem, yep. So we're going to do a little work off to the side here. We got to figure out what r is going to be. So to figure out what r is going to be, I'm going to do my Pythagorean theorem. So that's x squared plus y squared equals r squared. We figured out that x was 4. And we figured out that y was negative 5. And now we just need to figure out what r squared is. So I have 16 plus 25. And that'll give me my r squared. So 16 and 25 is 41. You square root both sides. Don't forget, whenever you square root both sides, you always need a plus or minus. Oh, we have to think about it again. So you're only going to get one answer. I'll go ahead and let you know the radius is always positive because it represents a distance. So unless you all own a time machine and can travel back in time, distance is always positive. So because the radius is a distance, you don't even have to really think about it too hard for r. R is going to be the square root of 41.
We don't have to write plus or minus, do we?
Our radius is always positive.
Oh, okay, my bad.
Yep, nope. Good question, I liked it. Okay, so we're tasked with two things. I have to find sine and I have to find secant. So, well, yeah, I have to answer the question.
Oh, okay.
Yeah. So the goal is to find the three letters. That way you could just use your formulas. Like sine is y over r. So if sine is y over r and y is -5, r is the square root of 41. This turns into -5 over your square root of 41. You can rationalize the top and bottom. Some of you can do that in your head at this point. So the very first answer, to find the sine of theta, to meet the goal of finding this piece, I'm just going to multiply the top and bottom by the square root of 41 there. And what I get out of that is -5 root 41 over 41. You may notice in this chapter that the numbers are a little weirder. You know, we're off the unit circle now. The radius is no longer 1. This time around, it's the square root of 41, so we're finding trig function values for really any angle. Getting how our calculator gets some of those funky numbers. Questions about that? Okay, wait, we're not done. We gotta find secant. All right, I need some help. Does anybody remember the formula for secant? Secant is your reciprocal of cosine.
Isn't it like r over x?
Yeah, sure is. Good job. Secant is r over x. If you think back to the chart in 1.4 part 1. Secant is for sure r over x. So in this case, r is the square root of 41 and x is 4. So that's it. Yeah, you got to ride the wave. Sometimes it's work, sometimes not so much.
Wait, how did you do that? How did you know?
How did I know secant was r over
Yeah,
x?
you just said my notes.
So secant is the reciprocal of cosine. Yeah, so if cosine is adjacent over hypotenuse, that's always an x value over an r value. To flip it, we would get r over x,
Okay.
or hypotenuse over adjacent.
Okay.
All right, that was fun. Let's do it again. Woo! All right. So here in example 2, again, your first mission is to figure out what x, y, and r are. I know, sounds weird. Okay, and we kind of do this again by looking at what we're given. So in this case, we are given the idea that tangent, so this is pretty similar to the last one, the tangent of theta is -15/8. And if I remember the definition of tangent as y over x, I know y is going to be something with the 15. And then x is going to be something with the 8. But I need to figure out where this negative goes. This guy right here, I don't know if it's supposed to go on the top or on the bottom. See that? So that's kind of why they give us this other clue here. I kind of like these. It's like a puzzle. So they tell me that the sign is negative.
Is it?
So sine, which value is it associated with? X, y, or r? Yeah, good. So they're actually telling me my y value is less than 0. In other words, my y value is negative. So basically that negative gets to stay up there. It doesn't go to the 8. Now, if I just swap this out with cosine is negative, well, the x would be negative on the bottom. Does everybody see that? That's the trickiest part, honestly. Y'all know the Pythagorean theorem. The numbers are going to be fine. It's just getting the plus or minus in the right spot. So, yeah, we've now gleaned that y is negative 15 and x is 8. So now I can just do the Pythagorean theorem, figure out what r is. So I'm going to do that. I'm going to do my x squared plus y squared equals r squared. So I'm going to do 8 squared plus negative 15 squared equals my r squared. So I got what? 64 plus 225 equals r squared. So r squared equals 289. When you square root both sides, we get plus or minus 17. But since it's the radius, and a radius is a distance, I can erase that minus. A radius is always positive. So a radius is going to be 17. So I know what x, y, and r are, just like you did last night. And so now what we're going to do is, it says find all 5 remaining trig functions. So they gave me tangent. I don't need to find that one. Tangent was given to me. That's negative 15 over 8. And if I just flip that, I get cotangent.
It's like you were right, we're doing it backwards.
Yes, it's backwards day. So you had to figure out what the x, y, and r are, and then write the trig function values. So I did tangent and cotangent. Remember that sine is just y over r. So you could just fill in what you know about y. That was negative 15. And then r is 17. And then the reciprocal of sine is cosecant. So I just got to flip that. And then cosine is just our x divided by our r, our adjacent over our hypotenuse. And x was 8 when r was 17. The reciprocal of cosine is secant, so I just have to flip that. So that'll be 17 over 8. Now's a great time to try one on your own. Let me set you up for some success real quick, though. Remember, if it says cosecant of theta is 4, there is a number under that 4, right?
1.
Yeah, good. So if you're looking at this, you know, if you're trying to sleuth out what x, y, and r are, cosecant's the reciprocal of sine, so this is going to be r over y. So hopefully that helps you get started.
Would you recommend us all?
You want to take a second to check it. Really zooming in on those 6 trig function values. So when you found x, you got negative square root of 15. So doing cosine, you're doing x over r. So it's negative square root of 15 over 4. And then if you flip that, you have to rationalize. So you got negative 4 root 15 over 15. Tangent's the square root of 15 over 15, but it has to be negative if you consider the constraint. And then cotangent had to be the negative square root of 15 too. So it actually works out. You do get a negative cotangent value like stated in the beginning of the problem. So I wanted to throw in a little division by 0 just to remind you of how that worked. So remember, our goal out of the gate is to figure out what x, y, and r are. And they're telling me here that sine of theta is 0, which is like 0 over 1, right? So if you remember that the sine is y over r, what they're saying here is that the sine of theta being 0 means that y is 0 and r is 1. So that's cool. So I'm going to put 0 for my y value, and my r value is 1. Then they give me this other piece of information. They tell me that the secant of theta is, we could say, -1 over 1. And remember, secant is the reciprocal of cosine, so this is r over x. Well, if you think about it, my radius can't be negative. So I have to take that negative and move it to where x is, because the radius, I mean, again, anybody here own a time machine? We can't go back in time. So we're going to take that negative and we're going to move it to the bottom. So yeah, my radius is still 1, but now I know my x value. My x value is -1. And now we just have to find our 5 remaining trigonometric functions. So we know sine. Sine of theta is 0. And the reciprocal of sine is cosecant. So if you, whoops, I wrote a theta there. Sorry, guys.
Wait, Lucas?
Yeah.
Whenever you move the negative, oh wait, never mind.
Right here?
No, no, never mind.
Okay.
Oh, thank you.
So the sine of theta is 0. And then if I flip that 0 over 1, I get 1 over 0, and that is undefined. So cosecant is undefined for this particular problem. And then we would go to cosine. You know, cosine is your x over r. So we got -1 over 1, and that's just -1. And then they already told us secant. Secant's -1. And last but not least, the tangent of theta is y over x. So if y is 0 and x is -1, tangent 0. If you flip that to get your cotangent, well, then you're looking at -1 over 0, and that spells no, you can't have that. You can't divide by 0, so that's undefined. So remember, a number divided by 0 spells no, that is undefined. A 0 over a number, though, 0 over 1, that's 0. That's on the number line.